Now for these next set of questions, we're just testing for continuity at x equals 2. Okay, so that means we only care about the continuity or discontinuity at x equals 2. So if x equals 2, that means the factor we're looking at is x minus 2. So I'm going to factor the numerator. That'll be x minus 5, x plus 2. That's what multiplies to negative 10, adds to negative 3. Remember, when it's just a 1x squared, you can just do what multiplies to this, what adds to that. So I can do the same thing on the bottom. So that will be x minus 2 and x plus 1. Now there's nothing to cancel. Okay. So we just want to look at the x minus 2 part. Okay, we don't care about this part because it's not where they're asking us to test for continuity. So since this is on the bottom, that means there's an asymptote, which is always non-removable. So this graph has non-removable discontinuity at x equals 2. And you don't have to write the at x equals 2 part on this one because they've told us what x value we're looking at. So we can just write non-removable because we know we're only looking at x equals 2. Now for 11, I first need to GCF out the x in the numerator. So that'll be x times x minus 2 times x plus 2 all over x minus 2. Okay. So these are going to cancel. Okay. Then again, we're just looking at the x minus 2 part. So since I was able to cancel those out, that means there's a hole, which would be removable discontinuity. Now on these next three, they've given us some function, but they said don't use this function when x equals 2. Okay, so we're going to use this graph except for when x equals 2. Okay, what we're going to do instead when x equals 2, we're going to fill this point in. Okay, so what we need to do first is factor this function. And then in the denominator, I'm going to factor out a negative so that I can cancel the x minus 2's. So these will cancel. Okay. So that means we have a hole at x equals 2. Okay. But this time I'm actually going to find the y value. Okay, because I know I'm going to have what's left. So the graph that I'm left with is x plus 1 over negative 1, which is just negative x minus 1. So what we're left with is just a linear equation. And then to find the hole, I'm just going to plug in that value of 2. So that's negative 2 minus 1. So I have a hole at negative 2, negative 3. Okay. So if we were to think about this on a graph, okay, we would have the graph of this line. So that would be y-intercept of 1, slope of negative 1. And then I would have a hole at 2, negative 3, so this would be an open circle. So my line would look like this. Okay, so that's what this graph would look like. Okay, so we have to think about this point right here, if it would fill that one in. So this is saying we have a solid point at 2, 3. Okay, so since the hole and the solid point are different, that's still going to leave a hole in the graph. Okay, so since these don't match and we had a hole at x equals 2, we still have removable discontinuity at x equals 2. Now if we look at this next one, so I'm going to factor this top into 2x and x, so I'm going to have to do guess and check on this one. So I do what multiplies to 2x squared, that's 2 and 2, and I would do what multiplies to 2. I'm going to do negative 1 and negative 2 since I'm trying to end up with a negative number. Well, I can't put the 2 here, okay, because I would be able to GCF out a 2, and I can't here. So I have to put the 2 with this one, and the minus 1 with this one. And then I can see that's minus 4, minus 1, which will add up to the negative 5. And then on the bottom, I'm going to have x minus 2. Okay, so again, they cancel. So what that means is I have a hole at 2, and then I'm going to plug that into what's left. So 2 times 2 minus 1 means I have a hole at 2, 3. Okay. Now I need to compare it to the point that they give me. Okay. So since they're exactly the same, this is going to be our solid point right here. So the f of 2 point is always the solid one. Well, since I have a hole at 2, 3, but then I'm going to put a solid point there, it's going to fill in that hole. Like if I came back to this graph, since the hole and the solid point are the same, it would fill it in and it would remove all of the discontinuity. So since these are the same, there's no discontinuity on this one. Okay. So we can just say that it's continuous, whichever you prefer. Now on this last one, okay, I've got an x minus 2 on the bottom, but I can't cancel it. Okay, so that tells us we have non-removable discontinuity. Well, if you have non-removable discontinuity, there's no point that's going to fix it. Okay, there's no point that's going to like fill in the graph and connect it and make it continuous. So if it's non-removable, we don't even care about this point. So since there's an asymptote at x equals 2, that's just non-removable discontinuity.